Okay, everybody, make sure that you have your note page titled 1-8 Graphing Inequalities. This is going to be the warm-up first to review what we did earlier in the week. Alright, so what I'd like to do is not to graph these functions, but to actually determine what the translations are happening with each of these. So obviously the first one is the parent function. But then what I want for the rest of those is just a brief description of what's happening. Moving left, moving right, moving up, moving down, how far is the graph flipped upside down. So the first one we can simply say absolute value of x minus 2, that's going to shift the graph down 2 units. So what I want you to do now is to pause the video here, copy the rest of the equations down, and then write afterwards what type of change you think happened, and then check them on your calculator. Now, then when you hit play again, I'm going to then give my solutions, but you should already know what the answers are because you've checked it with your calculator. So go ahead and pause now, try them, and then hit play and watch the rest. This should confirm what you saw in your calculator. Just remember, again, when we're moving up and down, it's exactly what you think it should be. We're going to add and subtract to the equation. But if I want to move left and right, remember that's along the x-axis, moving to the right, it's going to look like subtraction. And if you're moving to the left, it's going to look like addition. And then obviously, the negative out in front flips the graph upside down and reflects it. All right. Stop this video, and then we're going to go on to today's lesson, which is reviewing graphing inequalities. Okay, so again, make sure that your notebook is titled Lesson 1-8, Graphing Inequalities, and the question is going to be, how do we graph linear and other inequalities? And you did this back in Algebra 2. So we'll get some words like inequalities, shading, and our idea of solid and dotted lines. So let's see what you remember from before. So some things about graphing inequalities. Now just remember that when you're graphing a line, you're actually graphing a solution, or all the solutions, to the equation of that line. So with an inequality, there's even more solutions. So there's actually all these regions that would satisfy. So for instance, in this first graph, y is greater than x minus 2. A couple things to remember is that I'm just going to first treat it like a line, y equals x minus 2. And there's my equation of my line going along that dotted line. It's dotted because it's not equal to, so we're not including the line. And it's greater than, meaning that we're going to be shading above the line. So hopefully you remember some of that. So we can remember some things like solid lines are when I have the inequalities, and dotted lines, you might want to jot this down to remember, are just without the equal to sign. So for instance, in this first inequality, that if I have y is greater than x minus 2, what are all of the coordinates that satisfy that? So if I take the easy coordinate like 0, 0, is 0 greater than 0 minus 2? Well, 0 is greater than negative 2? Yes, that's true. That's why this point is in that region. That is the shaded region. Any point in that this shaded region would satisfy this inequality. Over here on the right, any point in this shaded region or on the line itself would satisfy this inequality. So I have the equal to sign, which is a solid line, and I'm less than, so I'm going to be shading below the line, and then all of those regions, any point in that region would then satisfy. So there I can see, it's hard to see in there now. Let me change colors to blue or yellow. So right here, this coordinate at 0, 0 Does 0, 0 satisfy? 0 is less than or equal to 2 times 0 plus 2. So is 0 less than or equal to 2 times 0 is 0, plus 2 is 2? Yeah, that's true. 0 is less than or equal to 2, so it's in the shaded region. So let's take a look at some other examples. All right, so now I'm going to start easy. So what I want you to do in your notebook is to write the inequality and then just sketch yourself a little graph. So let's see what these are going to look like. So y is greater than or equal to 3. First of all, we got to remember y equals functions are when all the y values are the same. So y is greater than or equal to 3. So just to keep in mind, that's this and this. So the line y equals 3 is up here at 3. I'm making it solid because I'm equal to, and I want to be greater, so I'm shading in everything above. Hopefully you remember these, and these are pretty easy. Y is less than 3. Okay, maybe write that equation, and maybe pause real quick, or inequality I should say, and then sketch it. And once you graph it, come back and turn it on. So I'm making a dotted line because it doesn't have an equal to sign, and I want all the values less than. So pick any coordinate in the region below this line, but not including the line. That'll satisfy that inequality. Let's keep going. All right, now, so x equals equations. X is greater than or equal to -1. Just remember, x equals equations were all points on the line that all have the same x values. So that is a vertical line, and it's going to be dotted. And now this one's tricky. Greater than or less than? Well, now, like, I can't go above or below it. So which way is greater than -1 on the number line? Well, that's clearly going to be to the right. So any point in that region, not including the dotted line, because it's not equal to, would be a solution to that inequality. All right, next one. Maybe how about jot this one down, maybe pause the video here, rearrange the equation, and then maybe turn back on and see what I'm doing. Okay, something to keep in mind here is that this gets a little weird, so I'm going to subtract x. So I get -2y is less than -x plus 8. I like trying to get an mx plus b form. And then I'm going to divide everything through by -2. And be careful. Dividing by negatives means I'm going to switch the direction of the inequality. So now it's going to be y is greater than +1/2 minus 4 after I simplified those. So first I want to graph the line that would be this case. Now it's going to be a dotted line, so I'm going down to 1, 2, 3, -4, and I'm going up 1 over 2, and up 1 over 2, and up 1 over 2. Okay, and that's where I'm going to want to make my dotted line. And I want to be greater, so it's all the region in here. So anything that's above the dotted line would satisfy this original inequality. I'm going to try a couple more here. Let's keep going. All right, maybe try this one on your own, and then maybe turn back on and see what I got. So greater than or equal to my line, y-intercept of -7, up 3 over 4 for my slope, including, because it's equal to, dotted line, or solid line. Same thing with the next one. Maybe try copying this one, pause, and then go ahead and try to graph. Now you can't, I'm not showing all my steps, but I subtracted the 2x over to the other side, divided everything through by -1, which then changed all of the signs and it changed the direction of the inequality. So down at -4, and I want a slope of up 2 over 1, up 2 over 1, up 2 over 1. All right. And I am doing a dotted line. And I want to be less than that line. So any coordinate that's in this shaded region but not on that line would satisfy that original inequality. All right, now I'm going to do some quick ones here. These are some review of what we've been doing the last couple days. So absolute value function, again, you can copy these down and then try graphing them without your graphing calculator. So this should be right 1 with a V. And this one's going to be left 3 and then down 2. So 1, 2, 3 and down 2. And I'm going to make my V from there. So some simple parent function changes. These are equations, not inequalities. So these should be. But now I'm going to change them. I'm going to make them inequalities. So now this next one. So again, pause whenever you need to. So I don't have an equal to sign, so it's going to be dotted. And it's an absolute value, which is going to be shifted 1 to the left. So 1 to the left. And this one's going to be dotted. So I'm going to do my dotted line. And now I want to be less than that absolute value function. So where is less than? Well, it's going to be all these, oops, let me get a pen back on, all these values that are less than the absolute value function, not including the dotted line. So the next one, does this look like a form I can work with it in? Well, let's actually add the 3 over to the other side. So I'm going to have 4 to the left, 3 up, and it's going to be solid. And absolute value. And I want less than, so it's going to be all of this space in here. So anywhere where the shaded region is, or on the actual line itself, that would be a solution to this curve. Almost there. All right. This one. Okay, so this one's a little bit trickier because it's actually made up of 2 inequalities. It's a compound inequality. So take a second and copy this down. You can pause it and then turn me back on. So what I'm going to do is I am going to break this into 2 inequalities. You can see one of them right there. And I'm going to jot that one down. Now I'm going to flip-flop it around. So I'm just changing the sides that they're on. Notice the inequality is opening up towards the y. It's still opening up towards the y. I just flip the left and the right-hand sides and switch the inequality with it. So now the other hidden inequality is here. So now I have a second inequality of y is less than 4/5 x plus 4. So I want, this is a system of inequalities, and if you remember this back from Algebra 2, I've got to graph both of them at the same time and find where the solutions are in common. So I'm going to let's start with the red one here. All right, so 3/4 x minus 3. So y-intercept of 3, up 3 over 4, down 3, back 4. This is a solid line. And now I'm not going to go hog wild crazy shading this. I'm just going to say this would have to be greater than. So I'm just going to put like little arrows saying I would be shading above this. So now I'm going to go and do the other inequality. So 1, 2, 3, 4. And I got a slope of 4/5. Oh, that would be off my grid here. So I'm going to go down 4, back 5. And then I know I'm going to do this with a dotted line. And where is this getting shaded? Well, it's less than. So I'd be shading down. Well, so if I'm shading above in red and below in blue, where are my solutions? Well, my solutions are then going to lie all in between. That's where they would overlap. And on this line, the red line, because that was included. So any point that's in the yellow shaded region in between or on that red line, now which is now yellow, would satisfy the original inequality. Now be careful, there are times when these inequalities, two lines would not necessarily shade between them, they could be shading outwards. So a real quick mention that if that happened, if I had a line going this way and I'm shading above, and a line going this way and shading below, are they going to intersect? No. So this particular graph would have no solutions. So be careful, don't fall into that trap. All right, so at this point now, got a worksheet for you to download. Again, if you're at home, you can print it. Otherwise, just do them in your notebook, sketch little graphs like we were just doing, all right? And then I'll have my solutions for you to check as well. Be ready with any questions next time that I see you or in Zoom or anything like that. We're going to have some questions coming up here soon. All right, good luck.